viewers of AraaTech, once again today we are presenting a new topic, Flask and Artificial Intelligence. Let's start the topic. Deploying machine learning models. Flask serves as a convenient way to deploy machine learning models into production environments. Once a model is trained and saved, Flask can wrap it in a web service, allowing users to send requests and receive predictions in real time. Flask's simplicity makes it easy to set up endpoints that accept input data, pass it through the model for inference, and return the results to the users. With Flask, artificial intelligence developers can expose the predictive capabilities of their models through APIs, web applications, or microservices. Building user interfaces for artificial intelligence systems. Flask enables developers to create user interfaces UIS for artificial intelligence systems, providing a way for users to interact with machine learning models without needing to write code. By combining Flask with HTML, CSS, and JavaScript, developers can design intuitive interfaces where users can input data, select models, and view predictions or analysis results. Flask's templating engine allows for dynamic content generation, facilitating the display of model outputs in various formats, that is, tables, charts, based on user input or model predictions. Creating interactive dashboards. Flask can be used to develop interactive dashboards that visualize artificial intelligence insights and data analytics in a user-friendly manner. By integrating Flask with visualization libraries like PLOTLY, BOKEH, or D3JS, developers can generate dynamic charts, graphs, and maps that update in real time based on user interactions or data changes. Flask routing system enables the creation of multiple dashboard views, allowing users to navigate between different visualizations and analysis tools seamlessly. Providing RESTful APIs for artificial intelligence services. Flask is well suited for building RESTful APIs that expose artificial intelligence services to other applications, systems, or devices. Artificial intelligence developers can define API endpoints using Flask's routing system, specifying URL patterns and HTTP methods, that is, get, post, put, delete, for data access and manipulation. These APIs can be used to integrate artificial intelligence functionalities into web applications, mobile apps, IoT devices, or backend systems, enabling seamless communication and data exchange. Microservices architecture. Flask supports a microservices architecture, allowing artificial intelligence developers to decompose complex artificial intelligence systems into smaller, independently deployable components. Each microservice built with Flask can encapsulate specific artificial intelligence functionality such as data pre-processing, model training, or result presentation, making the overall system more modular and scalable. Flask's lightweight nature and extensibility make it ideal for building microservices that handle specific artificial intelligence tasks or functionalities. In summary, Flask's lightweight and versatile nature makes it an essential tool in artificial intelligence applications, enabling developers to deploy machine learning models, build user interfaces, create interactive dashboards, and provide RESTful APIs for artificial intelligence services with ease and efficiency. Its role in artificial intelligence is crucial for bridging the gap between artificial intelligence development and real-world deployment, allowing artificial intelligence solutions to be accessible, usable, and scalable in various application domains. Integration with machine learning models. Flask allows developers to seamlessly integrate trained machine learning models into web applications or microservices. Developers can load pre-trained models into Flask applications and define routes to handle incoming requests for predictions. Flask's lightweight and modular architecture make it easy to incorporate machine learning functionality into existing or new projects. Exposing predictive capabilities. By integrating machine learning models with Flask applications, developers can expose predictive capabilities to end users via web-based interfaces or API endpoints. Users can interact with the deployed models through web forms, input fields, or API requests, receiving predictions or insights in real time. Flask simplicity and flexibility enable developers to design intuitive user interfaces that facilitate input data submission and display model outputs effectively. Versatility in deployment. Flask simplicity and flexibility make it well suited for deploying machine learning models in various settings, including web applications, microservices, and cloud platforms. Developers can deploy Flask applications on a variety of hosting platforms, such as traditional web servers, cloud platforms, that is AWS, Google Cloud, or containerized environments, that is Docker, Kubernetes. Flask applications can be scaled horizontally to handle increased traffic or demand, making them suitable for high performance and scalable machine learning deployments. Scalability and performance. Flask's lightweight architecture and efficient request handling make it suitable for deploying machine learning models at scale. Flask applications can handle multiple concurrent requests efficiently, ensuring fast response times and optimal performance even under heavy loads. Developers can leverage Flask scalability features to deploy machine learning models that serve large user bases or handle real-time data streams effectively. Integration with microservices architecture. Flask seamlessly integrates with microservices architecture, allowing developers to deploy machine learning models as standalone services that communicate with other components in the system. Each microservice can encapsulate a specific machine learning model or functionality, enabling modular and scalable deployments. Flask's simplicity and flexibility make it easy to orchestrate and manage microservices based deployments of machine learning models in complex artificial intelligence systems. In summary, Flask integration capabilities, versatility in deployment, scalability, and performance make it an ideal choice for deploying trained machine learning models in production environments. Its simplicity and flexibility empower artificial intelligence developers to expose predictive capabilities to end users through web interfaces or APIs, facilitating the deployment of artificial intelligence solutions in various settings and architectures. Building user interfaces. Flask empowers developers to create user-friendly interfaces for artificial intelligence systems, enabling seamless interaction with machine learning models and AI-powered features through web browsers, forms, input fields, and buttons. Flask allows developers to incorporate forms, input fields, buttons, and other interactive elements into user interfaces for AI system. Developers can use HTML forms and Flask's form handling capabilities to capture user input, such as text, numbers, or selections. Input fields and buttons can be designed to trigger actions, such as submitting data for prediction, selecting different models, or initiating data processing tasks. Data input and model selection. User interfaces built with Flask enables users to input data and select models or parameters for artificial intelligence tasks. Input forms can include fields for uploading files, entering text, selecting options, or providing feedback, depending on the specific requirements of the artificial intelligence application. Model selection features allow users to choose from a list of available machine learning models for algorithms, empowering them to customize their artificial intelligence experience based on their preferences and needs. Result visualization and feedback. Flask facilitates result visualization by providing mechanisms for displaying model predictions, analysis output, and visualization in the user interface. Results can be presented using HTML elements, images, charts, graphs, or interactive visualizations generated with JavaScript libraries. Flask templating engine allows developers to dynamically render content based on model predictions or user interactions, providing real-time feedback and insights to users. Templating engine and front-end technologies. Flask's templating engine JINJA2 enables developers to generate dynamic HTML content and integrate server-side logic into user interfaces. Developers can leverage HTML, CSS, and JavaScript to design visually appealing and responsive user interfaces for artificial intelligence applications. Flask seamlessly integrates with front-end frameworks and libraries like Bootstrap, jQuery, and Vue.js, allowing developers to enhance the UI with advanced features and interactivity. Responsive design and cross-browser compatibility. Flask enables developers to create user interfaces with responsive design principles, ensuring optimal viewing and interaction experiences across different devices and screen sizes. User interfaces built with Flask are compatible with various web browsers including Chrome, Firefox, Safari, and Edge, providing a consistent experience for users regardless of their browser's preferences. In summary, Flask's support for forms, input fields, buttons, templating engine, and front-end technologies empowers developers to create user-friendly interfaces for artificial intelligence systems. These interfaces enable users to interact with machine learning models, input data, select models, visualize results, and provide feedback seamlessly through web browsers, enhancing the usability and accessibility of artificial intelligence applications. Interactive dashboards. Integration with visualization libraries. Flask allows developers to integrate powerful visualization libraries like plotly, bokeh, or d3.js directly into web applications to create dynamic charts, graphs, and visualizations. These libraries provide extensive capabilities for generating interactive and customizable visualizations based on AI-generated data, such as scatter plots, line charts, bar graphs, heat maps, and more. Developers can leverage Flask's flexibility to seamlessly incorporate these visualization libraries into their applications and enhance the dashboard's interactivity and visual appeal. Dynamic chart generation. Flask enables developers to dynamically generate charts and visualizations based on AI-generated data or user interactions. Developers can use Flask routes to define endpoints that fetch data from artificial intelligence models, databases, or external APIs and pass it to visualization functions provided by libraries like plotly or bokeh. As users interact with the dashboard, Flask can update the data displayed in the charts and graphs in real time, providing dynamic insights and visualizations. Seamless navigation and URL mapping. Flask's routing system and URL mapping capabilities allow developers to create multiple views and pages within the dashboard and define how users navigate between them. Each view or page in the dashboard can be associated with a unique URL route, making it easy for users to bookmark and share specific dashboard configurations or analysis results. Flask's URL routing ensures that user can navigate between different sections of the dashboard, seamlessly enhancing the overall user experience. Customization and interactivity. Flask empowers developers to customize the dashboard's appearance, layout, and functionality to meet specific requirements and preferences. Developers can incorporate interactive elements such as drop-down menus, sliders, checkboxes, or input fields into the dashboard to enable user-driven interactions and data exploration. Flask's integration with visualization libraries allows developers to add interactive features like tooltips, zooming, panning, and data selection to enhance the user's ability to explore and analyze artificial intelligence insights. Real-time updates and streaming data. Flask enables developers to implement real-time updates and streaming data capabilities in the dashboard, allowing it to reflect the latest artificial intelligence insights and analysis results as they become available. Developers can use techniques like server-sent events, SSE, WebSocket communication, or periodic AJAX polling to update the dashboard's content dynamically without requiring users to refresh the page. In summary, Flask's integration with visualization libraries, routing system, and URL mapping capabilities make it an excellent choice for creating interactive dashboards that visualize artificial intelligence insights and model predictions. By leveraging Flask's flexibility and extensibility, developers can build dynamic and user-friendly dashboards that empower users to explore, analyze, and interact with artificial intelligence-generated data in real time. RESTful APIs. Implementation of RESTful principles. Flask allows developers to adhere to RESTful principles when designing APIs, ensuring that they are intuitive, scalable, and interoperable. APIs built with Flask provide standard HTTP methods such as GET, POST, PUT, and DELETE, allowing clients to perform data manipulation and resource access operations in a predictable and consistent manner. By following RESTful conventions, Flask APIs promote simplicity, modularity, and ease of integration, making them well suited for building artificial intelligence services that interact with a variety of clients and systems. Standardized communication protocol. Flask's support for HTTP-based communication enables standardized communication between artificial intelligence components, external systems, and client applications. Clients can interact with Flask APIs using widely adopted HTTP protocols, making it easy to integrate artificial intelligence functionalities into web applications, mobile apps, IoT devices, or back-end systems. Flask APIs abstract away the underlying complexity of artificial intelligence services, providing a familiar and standardized interface for clients to interact with regardless of the underlying implementation details. Versatility in API endpoints. Flask's lightweight architecture and extensibility make it ideal for implementing a wide range of API endpoints that serve various artificial intelligence functionalities. Developers can define endpoints for serving machine learning predictions, performing data processing tasks, executing custom artificial intelligence algorithms, or handling specific business logic. Flask's routing system allows developers to map URL routes to corresponding Python functions or classes, enabling fine-grained control over API behavior and functionality. Scalability and performance. Flask's lightweight architecture and efficient request handling make it suitable for building scalable and high-performance APIs for artificial intelligence services. Flask applications can handle multiple concurrent requests efficiently, ensuring optimal response times and throughput even under heavy loads. Developers can leverage Flask's scalability features to deploy artificial intelligence services that serve a large number of clients or handle real-time data streams effectively. Integration with microservices architecture. Flask seamlessly integrates with microservices architecture, allowing developers to build modular and decoupled artificial intelligence services that communicate via APIs. Each Flask application can serve as a microservice responsible for specific artificial intelligence functionalities such as model inference, data processing, or result aggregation. Flask's lightweight and extensible nature makes it well suited for orchestrating and managing complex artificial intelligence systems composed of multiple interconnected microservices. In summary, Flask's support for building RESTful APIs is instrumental in enabling communication between artificial intelligence components, external systems, and client applications. By providing a standardized and scalable interface for accessing artificial intelligence functionalities, Flask empowers developers to build robust and interoperable artificial intelligence services that meet the needs of diverse use cases and environments. Microservices architecture. Decomposition of complex systems. Flask allows artificial intelligence developers to break down complex artificial intelligence systems into smaller, manageable microservices that encapsulate specific artificial intelligence functionalities. Each microservice can focus on a distinct aspect of the artificial intelligence workflow, such as data pre-processing, model inference, result presentation, or interaction with external systems. Decomposing the artificial intelligence system into microservices promotes modularity, flexibility, and code reusability, making it easier to develop, test, and maintain individual components. Independent development and deployment. Microservices built with Flask can be developed, deployed, and scaled independently of each other, allowing artificial intelligence developers to work on different components simultaneously without impacting the entire system. Flask's lightweight architecture and modular design make it easy to create standalone microservices that can be deployed on various platforms, including traditional servers, cloud environments, or containerized deployments. Scalability and elasticity. Flask support for microservices architecture enables horizontal scalability, allowing artificial intelligence developers to scale individual microservices independently based on demand or workload. Developers can deploy multiple instances of a microservice to handle increased traffic, improve performance, and ensure high availability without affecting other components of the system. Flask's lightweight footprint and efficient request handling make it well suited for building scalable and elastic microservices that can adapt to changing usage patterns or resource requirements. Improved maintainability and testability. Microservices built with Flask promote improved maintainability and testability by isolating concerns and minimizing dependencies between components. Each microservice can be developed, tested, and debugged independently, allowing for faster iteration cycles and easier troubleshooting of issues. Flask modular design encourages the adoption of best practices such as code encapsulation, separation of concerns, and clear interfaces, leading to cleaner, more maintainable code bases. Flexibility and interoperability. Flask's lightweight and extensible nature makes it flexible and interoperable with other technologies and frameworks commonly used in microservices architectures. Artificial intelligence developers can integrate Flask microservices with other microservices APIs or backend systems built with different technologies, enabling seamless communication and collaboration across diverse components. Flask support for industry standard protocols and formats such as HTTP, JSON, and REST facilitates interoperability and integration with third-party services and tools. In summary, Flask support for microservices architecture empowers artificial intelligence developers to design scalable, maintainable, and flexible artificial intelligence systems composed of independent microservices. By encapsulating specific artificial intelligence functionalities within modular components, Flask enables faster development, easier deployment, and more efficient scaling of artificial intelligence applications, ultimately leading to better performance, reliability, and maintainability.